Welcome to the FOSS Balance in Motion instructional video. My name is Jeff Ryan and I'm the Science Education Director here at Olympic ESD. The purpose of this video is to give you, the teacher, some clarification on the learning targets for this particular kit. Let's go ahead and progress. First, I'd like to start by showing you this comes from the Framework for Science Education, the newly released frameworks, and the committee says by the end of second grade these are the ideas that students should, these are the pieces of knowledge students should have when they finish second grade related to force and motion. Here's a learning progression that we developed for this particular kit. Learning progression here shows the progression of learning given that the kit is taught in the manner that it was intended. Let me show you a little bit about this. First, this target curricular aim here. These statements here come from our Washington State Science Standards. And there's two of them that are on motion, and I'll say that this learning progression here starts at the second investigation in the kit. The first investigation is on balance, and from investigation 2 onward it's about motion and forces. Here are the Washington State Science Standards that are aligned to this particular kit, and this learning progression is available linked on this page as well. So a learning progression basically is made up of, here are the knowledge and the skills that students develop as you work them through this kit, as you facilitate their learning through this kit. These particular arrows here are pointing to what we call critical junctures in the learning. These critical junctures are opportunities for teachers to give assessments and orchestrate some conversation around the learning that has happened. So here's a better picture of the assessments. This particular assessment is intended to be given at the onset of instruction in order to elicit student preconceptions around motion and force. Now, a learning regression, the big idea here in the learning progression is classroom discussion and sense-making happens at those critical assessment junctures. That's where the sense-making occurs. Now, a learning progression sort of gives you this perception that learning occurs in this linear way. However, we recognize that that's not always the case. So let me show you an alternative learning framework that was developed by some researchers. This is an adapted from their Building on Learner Thinking, or BOLT framework. This comes from Anderson, Minstrel, and Lee, 2011. Anyway, the idea here is that the learning begins with the student ideas. And it's important for the teacher to engage those learner ideas. So in some ways, find out what do students already know about motion. And when possible, anticipate some of the common and useful and problematic areas. Teacher actions, you need to reveal and engage the student preconceptions and reasoning. And that's usually done through an elicitation question or an assessment probe. And there's also research out there that can support teachers with the student understanding. And Science Curriculum Topic Study is an example, and it's also linked on this page of where you can go. So, student ideas, then you begin the exploration of the kit, the activities, and the phenomenon. And then these red lines here represent the connection to sense-making. Sense-making is an ongoing thing that happens as the instruction of this kit or this module proceeds. Sense-making, when we talk about sense-making, what we're talking about is questioning that might come from those assessments, evidence-based explanations that the students are generating about the phenomena they're studying, and it really all hinges on discussion. The activities are not enough here. The sense-making has to occur, and the idea is that we are trying to get to the point where the class has some consensus that matches nearly what a scientist's ideas are for the phenomena that they're studying. And when we talk about scientists' ideas, we're really talking about the learning goals that include the conceptual ideas and also the science process skills that you're intending students to learn. The learning target represents the physical science standards, in this case from Washington State Science ELR 4 and also 1. And here, this is again the target. Enjoy teaching this kit, and please get into some of the other resources that are here to support you with this instruction.